All right. Okay, so interesting. I found out that my computer can both record my screen and can record the camera at the same time. Oh, I forgot to get water. Okay, hold on. All right. So, I'm changing my presentation because I recorded something that was solely using my only using the program and just my voice, and I feel like this would be better. So I'll split the screens in my video editing stuff. And if you're wondering why I'm looking over here, it's because this is where I can see myself. I have two monitors. It's right here. And yeah, okay. So interesting. I'm gonna go ahead and open up Creo Parametric, which is the program I use. And Creo, I have the free student edition because I am a student. Yes, I know, surprising. This is my so this is supposed to have two boxes, but it doesn't because the printer at my dad's work printed only one because it decided there wasn't enough space. So this one has been modified. Um, I have two rubber bands holding this in place, but hold on. Okay, so here we have the program, and hopefully I can edit this right so that you can see both me and the program, which would be really cool. So let me go to here, and my mouse just stopped working, which is really cool. Okay, all right. So maybe what I'm going to do is I'm going to demonstrate how this works first. So I have my screwdriver here. I can take this apart and show you all the pieces. Actually, no, I'll do that afterwards, after I show you what it actually does. Okay, so as you can see here, this is supposed to spin, and the issue I was running into is that when this spins, okay, sorry, keep moving. All right. So when this spins, it would hit the edge of the box because the box was not wide enough, and that's an issue, obviously. So what I did was I cut out. It took me like, well, once I figured out what I was doing, it took me like 20 minutes to cut those holes out. And I was just sitting there with a saw blade. No handle for the saw, surprisingly. I couldn't find one, so I just picked up one of the saw blades and I started going at it. And so, okay, here we have a rubber band to help hold this in place as I spin it. Hopefully it works. Again, it will work. It does work. It works without the rubber bands, but the rubber bands help. So I have the rubber bands on here because normally there would be a top box that goes over the top, and it would cradle this, just like the bottom box does, and it would keep it in place so that it would not be able to move anywhere. But obviously, there is no top box. So okay, yeah. So you get to see how this works. So, unfortunately, this crankshaft does not have a handle. My dad helped me design, and then he forgot to put the handle on, which is severely unfortunate. But I can still spin it, which is cool. So if we look at the model here, which you will be able to see, hopefully, you can see here that, hold on, let me rotate it, that there's this protrusion out on the side. So if you look here, there is no protrusion. It is just the crankshaft itself. And the protrusion was for a handle to go on, and you see the square end at the end here. Well, so it would stick out, right? It would stick out this way, and then there was a handle that you could just click on that would have the same square, the same cubical shape, and it would just be able to snap on, and then you could turn it like this. But unfortunately, we don't have that. So check this out. Let me see if I can do it like this. As I spin this, the piston moves up, and as it revolves back down, it moves down. And you see this axis, oh, it slipped off. Well, that's okay. It doesn't really matter necessarily. But as you can see, this axis right here stays the same, as this one moves up and pushes the piston up. So, which is interesting because now you have a spinning motion that goes this way, but you have this piston that's able to move up and down. So normally what would happen is, here, let's go to another model. Let's open up top box. Excuse me. What would normally happen is, so this is the top box. This is the piece that we're missing. And you can see here, it would fit just like that over the top of this. And yes, the piston would be in like this position almost. And okay, unfortunately, okay, well, let me show you. So we have this hole in the top, and what is this hole? So basically, this hole holds the piston in place and is kind of a guide for the piston. And so it makes it so that the motion of the piston is straight up and straight down. So normally you can see here there's a pin there, and if you look here, there is a hole there. And we didn't design a pin, and normally there would be a pin there. So if we go like this, I mean, the screwdriver works, but it's a little bit ghetto. It doesn't really work. If you go, yeah, I know, okay. If you look at it now, the piston head here, this is called the piston head. The piston head can now move like this, moves back and forth. And why do we need that? So what's happening here, we'll move this to top dead center. That's what it's called when it's fully extended. Almost there. Okay, perfect. So this is called top dead center, sorry. So you can imagine if this piston head is fixated in place, and it's only allowed to move straight up or straight down and straight up, right? Then what would happen is this piston arm would need to be able to move outwards like this. So it's really hard to move. If you can see that, you can see the piston arm moves like this. It moves like this. And that's because instead of the actual cylinder head, the piston head moving, the piston rod will move instead. And that makes it so that it can go straight up, straight down. Okay, so sorry that I can't really show that with my current creation, but you can understand the basic concept. So I found this video, hold on, and you can understand a little bit better with this video. So here, let me back it up. This is basically it's the same concept as a single cylinder engine. And so, okay, let's play the video. You see here, we have our piston head moving up and down. It's stationary, and you can see the yellow there. The yellow part there is the piston arm, which is this right here. And you can see it moving back and forth. And so one of the issues with this is that I need to, I redesigned it, but there's not enough plastic, obviously. So, but here, we'll take this off. as it goes down and it moves to the side, right? It goes like that, and it's like at an angle, right? So at an angle. Let's pause that video. At an angle. And so this needs to go straight up, but unfortunately, there's not enough room inside here. You can see I tried carving it out. There's not enough room inside here to allow for that arm to go at that angle. So I would need to cut out. Excuse me. I don't have COVID, I swear. I just need to drink some water. I just need to cut out a notch out of here so that the piston arm can move freely, right? Because when it's at this angle, the holes don't line up, and that's an issue. So I redesigned it though, and I'm going to reprint out the whole thing next week, and maybe I could submit a video to Miss Kelly, and maybe if she was so inclined, she could show the rest of the class, but like next semester or something. But yeah, so that's this. So okay, let's take it apart. Here we have piston box, right? A little bit too small. That was the issue. I redesigned it. I redesigned everything actually. So once I go to reprint it, it will be perfect. It will be perfect. So let's look at our other models here. So we excuse me. We saw the top box. All right. Let's see. We saw the crankshaft. Crankshaft handle. Okay, this is cool. So, crankshaft handle. You can see here the square end I was talking about. This crankshaft handle would fit on that end, which is very, very cool. So it would fit on the end, and you can imagine you would hold that handle like this, and you would be able to twist it. Right? Pretty simple. But, okay, yeah. And there's lots of cool things on this program that AutoCAD either doesn't have or has hidden. And I don't know everything about AutoCAD or this, but I feel like this one was more intuitive. I liked this program a lot better because it's made more for 3D objects. Let's see here. Okay, bottom box. So you can see this box. This box is much thinner than the thickness of this one, and it's also wider, which is very important. And yes, you can see here that, oh my gosh, someone is calling me. You can see here we have these dimples, and these dimples are so the top box would have the opposite, and it would click into place, and then we could drill a screw through it. That was kind of my dad's idea, but I changed it. Instead, here you can see the holes, and the top box has protrusions that will just click into place. And I mean, we could glue that, or we could just leave it as is so that you can like dismantle it. So yeah, okay. Oh, all right. We'll open up the piston head. Oh, okay. So this is my piston head redesign. You can see the notches cut out so that, let's see. Imagine this, right? Because piston arm right here, and it would need to move back and forth, back and forth. And so we have those notches cut out to allow for maximum movement, so that even if the piston arm had to go out at an angle like this right here, it could. And that's completely unnecessary, but I just wanted to make sure that when we print it out, we wouldn't have to do any extra editing. So yeah, there's that. Let's see. Piston head, piston pin. I designed a pin. Pretty simple, just a cylinder. It has the exact dimensions. Oh, it would be cool to show you. So the dimensions are hidden in there. If you want to see them, you say show dimensions, click on the object, and then we can go ahead and show both of these. Boom. Now we have our dimensions here. Hold on, let me full screen this. 0.66, or is that right? Oh, 0.99. Sorry, this is upside down. There we go. 0.99, and we can drag this out here so that we can actually see the dimension there. And then the circumference, I don't know why it's like that. We could change that technically. It's 0.22, which I determined was optimal for the hole. So yeah, and then we click off and it's done. And then I have to save this now. Okay, we're good. We'll go ahead and open up Piston Rod. Okay, Piston Rod. So here we are. Let me take this apart now. Where's my, okay, here it is. Okay, let me take this apart and show you exactly exactly how we did this. So this is how they do it in a real engine. In a real engine, the piston rod does have two parts because the crankshaft, so you can imagine, the crankshaft is what's in an engine, it's what's delivering all the power. In this creation, it is also what's delivering all the power. So we want it to be one solid unit so that it's not weakened in any way, because there's so much force just going through this at once. It would be hard to have it in more than one part. So unless, like, you know, you had bolts or whatever. But so here we have this 1/2 of our piston rod, and you can see in the drawing here, this is the same thing, right? We have all our dimensions. This half, see, that fits over, half of it fits over the crankshaft here. Click. Fits pretty good. Does a little squeaking. That's okay. I should have probably put like some type of lubricant or something, but whatever. It works. Okay, so there's 1/2, and you can see here we have these dimples in it, and then a smaller hole, and that's the pilot hole. So, okay, let me explain that. We'll open up another, and this is the piston cap. So you would imagine looking at this, right? This isn't going to stay on here by itself, obviously. So we need to have the second half. And of course, you know, the other option is we can't have this be one solid object, or else how are you going to get it on here? So we divide it into two. So we have the cap. And this is what the cap, well, the current design cap looks like. And in the updated one, I changed it. Oh yeah, I also made these edges here curved to fit better. Also looks cooler, not gonna lie. So here we go. Let me move that out of the way. Hold on. Okay, check this out. So as you can see, this cap, pretty boring, pretty normal. Just has the holes, holes on one end, holes on the other, and it fits over the 1/2 of the shaft. So what's important is that these holes are big enough so that the screw can just fall right through. And the reason why that's important is so that when this screws into place, it doesn't push it out. It doesn't, because as you're screwing this into place, it's like really hard. And what it does is, instead of screwing in, it just screws through the threads on this side and then pushes this out and doesn't screw in. So you need to have this loose. So, but in the updated design, I resolved an issue that I will explain in a second. You can see these little nubs on here, and they fit into place on the other one. And let's take a look. They fit into place in these holes. And, excuse me, these holes, if I screw this back into place, let me do that really quick. Gosh, okay, sorry. I'm blind. Okay, so I've screwed it back into place. You can kind of see that these aren't exactly lining up. And the issue that these like Lego pieces basically resolves is that it lines it up for you so that you're not sitting there trying to screw it in, you know, by looking at it with your eye. So it just kind of lines it up for you. All right. I don't know if there's any more models. I don't remember. I don't think there is. I think that's all. So let's put it back together for a final demonstration. I need my water. Okay. Before I die, all right, check it out. Up, down, up, down. It's pretty cool. It's pretty cool. Once I reprint this and I have the handle, I mean, it's gonna be really cool. Like, an issue with this also was that you can see here, there's a lot of play. This moves back and forth and it doesn't really fit perfectly, which is why I had to make these so big. You can see the width of this isn't very wide, but I made these so big because these holes in the side, because I knew that as I spun it, it would move side to side, and if I didn't do that, then it wouldn't line up. So yeah, that's my project. So you can imagine this is spinning very fast, and you have an axe attachment on the end of this, and it's sticking out of the top of this box, right? So imagine, there's a box right here, right? And it's moving super fast, in and out, and there's an axe, and it's slamming this tree. It's just absolutely decimating it. Clears your fire line in seconds. Boom. Yeah, so that was my project. It was very fun, very interesting. I'm going to reprint all of my parts to make an actual model because I think it's really cool. I really enjoyed Creo, the student edition. And I'm sure if you watch just like a couple videos, you could figure out how to use it. It's really, yeah. So that's all. Yeah, pretty cool.